So first of all, I wanted to thank the organizers for giving me the opportunity to speak here at this conference today. My name is Manuel Reiband. I'm responsible for turbine sales management in the Asia-Pacific region for Vestas. Okay, so the title of the presentation today is Value Propositions of Renewable Hybrid Power Plants. And I think it seamlessly connects to the previous presentations we have just seen from the colleague at ENGIE. I think operators and owners of plants, thank you, as well as technology providers have to work together even more closely in the future. And this does not only apply to us, but also to regulators and probably to everyone in this room in order to make it happen in Mongolia as well. But let me start with an introduction to our company. Instead of showing a lot of numbers, I just wanted to show this photo. It was taken recently here in Mongolia. We are very proud to be delivering the second wind farm in this country. And I think this really encapsulates what we at Vestas are passionate about. There's a few numbers, you can look them up in the papers that were distributed. Now, why are we here? I think it's really important to understand the context of this country. Since 2000, and similar numbers have been presented earlier today, there has been a steady growth of around 5% in per capita electricity consumption. And I certainly believe that will continue, especially if you take into consideration that the population of Mongolia is also growing. So there is an expected growth in electricity demand. More importantly, if you compare that to the upper curve on this slide, this is actually the per capita electricity demand of Denmark. So you can see that there is still quite a gap to be filled. Now, at the same time, the chart on the right-hand side shows that at least since 2000, Mongolia has actually been a net importer of electricity. And as you can see, towards the right, this has been increasing quite drastically a few years ago with the opening of a new mine. Now, I think that Mongolia should not be a net importer of electricity. If you look at the map that we've printed here, it shows that there are abundant resources, not only for wind energy, but also for solar energy in this country. So there's no reason why Mongolia should be importing electricity from its neighboring countries. We're definitely here to support that transition. We're already, like I said, delivering the second wind farm in this country, and I very much hope that there'll be a lot more of wind farms that we can build here in Mongolia. But of course, we have to understand the challenges that this also puts on the grid here, and we've heard some very good discussions already earlier today. I think it would be naive to assume that we can just continue building wind farm after wind farm. Because of course, one thing is to look at the average of electricity consumption over a full year. In reality, it's a bit more complex, and you have to look at the time of that generation, and you have to understand exactly when the electricity is produced and when it is consumed. And unfortunately, there is a misbalance between those two things, and that is something that we cannot ignore. On the contrary, I think it's something we have to embrace, and we have to work together in order to find solutions to solve that. There are technologies out there. We have just seen that ENGIE has already successfully implemented that. We are successfully implementing technologies that allow this in Australia at the moment. What it requires is an intensive collaboration, and it requires also for everyone who's involved to take a bold step forward and to think outside the box, and then it's possible. So in order to transition to the discussion of hybrids and to put some structure around that conversation, I'm using these three paradigms of the renewable energy industry. When our industry started to really pick up in 10, 15 years ago, what we needed to deliver was clean energy, and that was relatively simple if you could get the technology to work. On the remuneration side, there were feed-in tariffs. In all markets, we also saw information that provided earlier. So it was a fairly straightforward business model. As we've already discussed a lot earlier today, auctions have really changed the paradigm. And auction introduced the notion that renewables should not only be clean, they should also be cheap. So over the last few years, we have seen drastic reduction in the tariffs. I think it's also important to note that it doesn't only go one way. We have recently seen in Germany that the last auction closed at a higher level than the previous one. The same happened in India. So the introduction of auctions doesn't necessarily mean that the prices will go down in all eternity. We have observed that for some time, but it seems that the trend right now is reversing and we see increasing bids. But now comes the interesting part, the third paradigm of renewables. It's not enough anymore to be clean and cheap, we also have to be reliable. The penetration of renewables is so high in certain markets, Denmark being a great example, that it causes system instability in the worst case if we don't manage it appropriately. Now in Denmark we do manage that very appropriately. Like I said, the technology is there, but it does require a very intensive collaboration. So we have observed these developments and taken the decision to change the vision of our company. We are known for, and have been known for the last 30 years, to have the vision to be leading the wind energy market. And I think we've done a good job in doing that. We have not changed our vision statement to being leaders in sustainable energy. Now that is only one word that we changed, but it's actually the most important word that we took out of our vision, being wind, and replacing it with sustainable. That means that we're very much opening the horizon and the playing field on which we are, as a technology provider, working with our customers and the societies. Our journey in hybrid has started already 6-7 years ago when we installed the first 2 pilot projects in Denmark. One of them was a battery that was connected to a wind farm, and that battery is providing ancillary services to the Danish network. So we're providing voltage control and frequency control services. And actually, even though it was an R&D project, it's a small profit center for us in the company right now. Of course, this requires that such policy exists, that this regulation is in place, and that the market signals are efficient. And that's something that was also brought up already today. I think it's something we would be glad to engage with the community here in order to provide our view on how this can be designed. We've also built a co-located PV and wind farm already in 2012, and have since then captured the learnings from what happens exactly when you connect a wind and a solar plant together. Last year we decided with one of our clients and partners to build another pilot, actually integrating the PV plant directly into the converter system of the turbine, so that is a deeper integration in terms of the technical solution. It's just been commissioned recently, and we're now analyzing the results and the performance of that. But more importantly, we have closed the deal on the Kennedy Energy Park in Australia, which is the world's first and biggest utility-scale power plant that combines wind power, solar power, and a 2-megawatt battery in one system. So our scope within that is obviously to deliver the wind farm, but we've also supplied the control system, the brain that allows these 3 subsystems to work together in a seamless manner and to be grid code compliant in Australia. I guess the newest element in hybrids does not relate to hardware, and that is another discussion where we have to start shifting away from the old focus of the renewable energy industry. It's been about hardware for many years. I think now we have to start thinking about the brains and the software part and giving a lot more attention to that. We have taken steps by acquiring a software company called Utopus Insights earlier this year in order to really leapfrog our own position within the digital space. Okay, but going back to the hybrid proposition. So lots of articles and white papers today talk about hybrid solutions. What I find interesting is that very few people talk about the problems. Right? So obviously when you want to talk about a solution, you have to put it into the context of the problem you're trying to solve. And I think this is really where a lot of discussions are still to be had. There's, the technology can do many things, especially talking about batteries. You can store energy for a long time in a battery, but you can also release big amounts of energy in a very short time frame. Those are two very different requirements, and they will lead to very different technology solutions. So I think before we jump into conclusions and talk about having this or that battery installed here in Mongolia, I think we should spend some more time in talking about what problem are we actually trying to solve. Are we trying to solve grid stability problem, or are we trying to solve the problem of importing electricity from neighboring countries? Those two will require very different technology solutions. They're both possible, by the way. So in order to provide a bit of a framework for this discussion, I've segmented 3 different layers of potential applications for hybrids. The first one is a plant that operates under a fixed PPA, under a fixed feed-in tariff. Right? So this is the case that we have in Mongolia today. If an owner of a wind farm or a renewable power plant has a fixed tariff, then their main incentive is to reduce the cost of electricity of that plant. That means that we have to think about how we can combine different technologies that will allow the hybrid plant to deliver cheaper energy than standalone assets. In this case, it would be nonsensical to add a battery, because the battery will actually increase the LCOE. A battery cannot generate any electricity in its own right, but it costs money, which means that it will only impact the LCOE in a negative way. So that's why here the integration focus will be between wind and photovoltaics. The critical part here is to understand exactly how to balance the capacity of those two subsystems, because you want to optimize the size of your electrical infrastructure. The next segment is then what we see emerging more and more in other countries, and Australia is probably the spearhead in that sense. Someone mentioned earlier that we may soon be able to have renewable power plants operating in a subsidy-free environment. Well, actually in Australia there are already such plants being financed and built today, some of them even with project finance. So it's a reality today that hybrids can participate in an electricity market without having a long-term PPA. Some with layered shorter-term PPAs, and some simply by selling into the spot market. So here it's now more interesting to look into battery storage, because you will be able to optimize not only the cost of energy, but you will be able to optimize the way that you deliver electricity to your customers. And then finally, there is the captive place. This could be mines, this could be utilities, who are looking at either augmenting their energy, or replacing or even displacing fossil fuel generation. So again here, the technical solution that you're looking for is very different. The technology is available, but you have to integrate it in a different way. So this is an image that shows what happens when you combine 3.3 megawatt of a wind turbine, so one turbine, and 1.5 megawatt of PV, and a small battery in an environment of relatively low wind conditions. So obviously this is scalable. What we have seen in this study is that a turbine alone could achieve a 39% capacity factor. Adding the PV could increase that to a 45% capacity factor, keeping that same export limit of 3.3 megawatt. Right? So the two resources really complement each other very nicely, and the battery even allows for energy that would be curtailed in certain instances to still be applied and delivered to the customers. Now, of course, what's important to note is that this is an average observation. We have done a very detailed analysis of a site here in Mongolia, and we have found that there was an event in the middle of December 2013 where for 9 consecutive days there was almost no wind at all. And then obviously being December, the generation from the solar plant was not at its highest either. So this is where we really have to go into the details to understand how are the conditions on a specific site and how can we deliver technology that enables to the requirements of the customer and what exactly you're looking at. But just to give a bit of insight into what we're doing on the digital space, I wanted to finalize my presentation with a short video.
Today, we live in an increasingly connected, measured, data-driven world that produces a tsunami of data. Turbines and solar panels do not stand alone anymore. They are part of an emerging energy ecosystem that is becoming decentralized, decarbonized, and digitized. Welcome to tomorrow. The global energy sector is transforming fast. Without new thinking, one could get lost in this fog of data. We are here today to embrace this digital energy revolution, to harness the unlimited distributed energy resources, to deliver previously unimagined predictability as we increase renewable energy production, more efficient operations, and better integration with energy grids. The revolution began with advances like cheap hardware, cloud computing, and fiber optics. Today, we add the critical joining of the world leader in wind with best-in-class data analytics software from Utopus Insights. Today, we deliver action-driving insights to connect you in real time to the state of your system. Pattern recognition and sensor data to intervene before failure occurs. Cutting-edge forecasting tools to turn intermittent energy sources from fickle to predictable. Greatly optimized wind farm production. Real-time customization of nearby individual turbine pitch and yaw to maximize overall energy production. Control all aspects from fine-tuning a fleet of turbines to the timing of storage. Today, Utopus and Vestas join to create a world where a smart system responds precisely to human needs, to meet the needs of the grid today and tomorrow, to meet the grandest challenge of our warming world, to finally unlock the vast potential of renewable energy. Today, we join data science with sustainable energy science for a clean, abundant, reliable, affordable energy future. Welcome to a connected tomorrow, today.
Thank you very much.